Okay, so 3.9 for Algebra 2 talks about nonlinear system of equations. So if you have two or more equations that are solved together where at least one equation is nonlinear, okay, meaning that it has like an x squared or an x cubed or a square root of x, okay? So linear would be just an x, right, and just a y, okay? But if it has an x or a y that's to a different power, then it's nonlinear, okay? And the equations have to have at least two variables. So at least, an x and a y, because you have to be able to solve for both of those. Okay, so that's a nonlinear system of equations. So the solution set of a nonlinear system. So the solution set of a nonlinear system of equations are all the x and y values that make all the equations in the system true. Okay. In other words, it's all the points where the graphs of all the equations in the system cross or intersect. Okay. So remember, when we have a linear system, okay, we have two lines here, okay, that intersect at some point, and that x, y is the solution to the system. Well, now we're going to have things like parabolas, lines, circles, okay, that all intersect. Okay, and they may intersect at more than one point because there's different shapes now. Okay? So all of those x and y values are solutions. Okay? Let's actually take a look at how many solutions there can be. Okay, so if the system has no solutions, okay, then it means the two graphs never intersect. So something like this right here. So it could be a circle or an ellipse or whatever, but just two graphs that are never going to touch for whatever reason. Okay. If the system has exactly one solution, then it's something like this where they just bounce off of each other. So this one right here is called a tangent line. So yes, it looks like it might touch here and here, but really remember that lines have no thickness in the definition of them. So it is only going to touch at one point. The next one, this graph has several solutions because the two graphs intersect at several points. Okay, so here you're having it intersect at 2 points. It could intersect at 3 or more points, just depending on what the graphs are. Okay, we don't usually get into any other than 2 points, even in pre-calculus. And then this one, the system has infinite solutions. So this one would be a graph, and maybe the equation of it looks different than the equation of it in another form. And so, like, I can tell you right now that this graph, okay, is a parabola, okay, and the form of it that would look different would be something like this. Okay, and those are the exact same thing. They're the exact same parabola, but they look different. Okay, so it would be two parabolas that essentially are the same, they overlap, or two circles that are the same and they overlap. Okay, so infinite solutions means it's the exact same graph. It just might look different in the form that it's written in. Okay. So we do not ever use graphing method for the same reason we didn't like using graphing method before, because it's just not very accurate. Okay. So we're going to use the substitution method. Okay, so the substitution method, we're always going to solve one equation for one variable. And it's always going to be easier to solve the one that has no squareds or cubes or square roots on it. Okay? And then we're going to replace the variable with the other one, okay, with the solved equation, and then we're going to solve it. Okay, so let's actually walk through it because it's a little bit easier to do that. So this one right here, the first thing I see is that if I divide both sides by 3, then I can get x equals 2y really easily. Okay, so I know what x is. Okay, x is 2y. So in my other equation here that I didn't solve, anywhere I see an x, I'm going to plug 2y in. So I get 2y squared plus y squared equals 25. Okay, now I'm going to square this. So remember, I have to distribute that squared to both of these. So it's actually 4y squared plus y squared equals 25. And now I'm going to go on ahead and combine my like terms. So I get 5y squared equals 25. Okay, I need to solve this. So I'm going to divide both sides by 5. Okay. Okay, so I get y squared equals 5, and then I'm going to take the square root of both sides. So I get y equals 5. Now, really, I can stop here because when I plug it back in, okay, I know that I'm going to get the same thing. Okay, so really, it's going to be the same thing. But let's go on ahead and let's plug it back in here. So I get x squared plus y squared equals 25. Okay, so I'm going to get x squared plus my y squared, okay, which I know is 5, equals 25. Subtract 5 from both sides. Okay, and I get x squared equals 20, and then I can take the square root of both sides. Okay, so I'm going to get x squared equals the square root of 20, which comes out to, let's see, 4 times 5, which comes out to 2 root 5. Okay, so if I plug 5 or square root of 5 in, okay, that's what I get. But remember, okay, that I really have to have the plus and minus square root of 5 in there. Okay, so if I plug in the square root of 5 negative, oh, I wrote these backwards. That was actually my y value. Okay, so 2 square roots of 5, and that's with the positive square root of 5, okay, because that's really what my y is. Okay. Then if I plug in the negative square root of 5, I get the same answer when I square this. Okay, so it's still going to be positive 2 square roots of 5. Okay, so these ones get a little bit more difficult because you have to plug in, and I did it again. You have to plug in both the positive and the negative. Okay. All right, so now let's go on ahead and take a look at this next one. Okay, and really, if you just plug in that y squared equals 5, okay, then you're going to see that it's going to come out with both answers for both the positive and the negative here. Okay, so you don't have to do it twice. Okay, it's just a shortcut. Okay. All right, so let's take a look at this one. So this one right here is already solved for y. It's x squared plus 3. So now I'm just going to plug that in. So I have x squared plus y, which is x squared plus 3 equals 9. Okay. So now I'm going ahead and I can solve this out. Well, guess what? X squared plus 3 squared. I'm going to have to figure that out. So that's x squared plus 3 times x squared plus 3. Don't just say, oh, that's x to the 4th plus 9, because that's not the case. Okay, so it's going to be x to the 4th plus 6x squared plus 9. All right, so now I'm going to have x squared plus x to the 4th plus 6x squared plus 9 equals 9. Okay, so now I'm going to go on ahead and I'm going to subtract 9 from both sides, and I'm going to combine my like terms. So I have x to the 4th plus 8x squared equals 0. Okay, what can I take out of here? I can take out an x squared. Okay, and I'm left with x squared plus 8 equals 0. And now I'm going to go on ahead and solve it. So remember that I should have 4 answers here because my biggest value there is 4. Okay, my biggest exponent. So I'm going to have x squared equals 0, which means x is going to equal plus or minus 0, right? So really, you don't have to include the plus or minus, but remember, that's 2 answers right there. Okay, so I set that equal to 0. Now I'm going to set this piece equal to 0. X squared plus 8 equals 0. So subtract 8 from both sides. X equals negative 8, okay, or x squared. Take the square root of both sides. And so now I get x equals plus or minus, okay? The negative sign comes out as an I, and the 8 breaks down to 2 times 4, okay, which is 2 times 2. So that's 2i square roots of 2. Okay, so we have those 4 answers. Okay, so these actually cross in 2 places. Okay, and it makes sense because this right here is a circle. Okay, and this right here is a parabola. Okay, so if you look at the graph, actually, let's just graph. And it'll be easier here just to show you on this, because otherwise I have to solve this one to enter it. Okay, so x squared plus y squared equals 9. So that means it's a circle with a radius of 3. Okay? And you guys will learn about how to draw these in the equation form a little bit later. Okay, so yes, that's not a perfect circle, but that's okay. Okay, and this one is a parabola, okay, that has been moved up to 3 here. Okay, so it looks like that. Okay, but remember, these imaginary numbers aren't going to show right there. Okay, so now we've got our x's. Now we're going to have to plug it back in and get our y values. Okay, so if we plug 0 in here, we get 3. Okay, so our points are going to be 0, 3. Okay, and if we plug this plus or minus 2i square roots of 2 in, or we can just plug x squared, we know x squared equals -8. Okay, so I can plug that in here. Okay. So y equals -8 plus 3. So I'm going to get -5. So I'm going to get plus or minus 2i square roots of 2 and -5. Okay, so those are going to be my answers here. So somewhere down here, I'm going to have on the imaginary axis a place where they cross. Okay, but the only one that we're going to see in real numbers is that one. Okay? So those are my 4 answers. And because remember, 0 is actually a plus or a minus. Okay? All right, so I know that, sometimes this can be a little bit hard to understand. We are going to get into more detail on it later. And we are going to get into where we have 3 variables, so x, y's, and z's here, and we have 3 different equations that we're solving. So it's really important that you guys understand how to solve a solution and what the solution means. Remember, the solution just means where these things touch. Well, we're going to go ahead and take a look at 310 now also. So 310 talks about graphing inequalities. Okay, so the boundary between the 2 regions is the curve. Fill in the blanks with the correct inequality symbol. So a solid curve. In other words, if you're drawing your parabola and it has a solid line on it, that means that it is greater than or equal to or less than or equal to. So one of my students said, if it's got a line under it, then it's a line. Okay. So if it's a dashed curve, in other words, if it's like this, okay, that means that it's just greater than or less than, okay, because it does not actually touch that parabola. Okay, so now we're going to have to look back at some of our rules. So remember here, we're going to have to actually graph it just like if it was a regular parabola, okay, without that inequality symbol. Okay, so I know my y-intercept is 0, 6, because remember that's always our c value. I have to find my x, so x equals -b over 2a. Okay, so -4 over 2 times my a value, which is 1. Okay, so -4 divided by 2 is -2. Now I have to find my y value by plugging that -2 back in. So it's -2, and remember in your calculators, you need to put that -2 in a parenthesis, okay, because your calculator will do this and give you -4 because it squares the 2 and then multiplies times -1, okay, if you don't put the parentheses. If you do this, then it does -2 times -2, and it gives you a 4. Okay, so really important to remember that. Okay, plus 4 times -2 plus 6. So here I'm going to get 4 minus 8 plus 6. So that's 10 minus 8. So that's 2. So my vertex then is -2, 2. So -2, 2. Okay, and I know it's going to cross here at 0, 6. Okay. I know that it is going to be a solid line, okay, because it's less than or equal to. Okay, and now I just need to find my pattern. So my 1a over 1, 3a over 1, 5a over 1. Okay. So 1 times my a value, which is 1 over 1, is just 1 over 1, 3 over 1, 5 over 1. Okay, so I'm going to go up 1, out 1 on both sides. And from there, I'm going to go up 3, out 1. Good. I hit my y-intercept. I should. Okay. And then I can keep going if I wanted to. So up 5, out 1, up 5, out 1. Okay. And it's going to be a solid line. We already decided that. Okay. Because it's got the line under it. Okay. And now we just have to know where to shade. So if it's less than or equal to, that means that my y value is less than my parabola. So it's under my parabola. So I would shade under my parabola. But remember, that also includes everything out here. Okay. The other option, what I always like to do is choose 0, 0. You don't want to choose this if it's actually on the parabola, but since it's not, I can choose it. and I'm just going to plug it in there. So I'm going to have 0 is less than or equal to 0 squared. So I'm plugging in my y value as 0 and my x value as 0. 4 times 0 plus 6. So I get 0 is less than or equal to 6. That is true, and I always shade where it's true. Okay. So if it had come out as false, I would know that I didn't shade out here, that I would have had to shade in there. Okay. All right, let's take a look at a couple more of these. So it says list the points on the graph that satisfy each inequality to the right. Okay, so y is less than x squared plus 6. Okay, so less than. Okay, so the parabola, this equation is x squared plus 6. You can see that that's each of these. Okay, so y is less than. So less than, the points that are below it, okay, are going to be E and B. Okay, let's take a look at just greater than. Okay, so does not include it. Okay, so just greater than is going to be points D, and it looks like C is not on the line, so D and C. Okay, but now we have to look at less than or equal to. So we already know that less than is E and B. Okay, but then or equal to would also include the two that are on it, F and A. And then the same thing for the greater than or equal to. So we already know that D and C are greater than, but we also have to include the equal to, which would be F and A also. Okay. So that's just looking at where less than, where greater than of parabolas are. Okay, so greater than, if it's a parabola going up, is going to be inside of it, right? So greater than, greater than, greater than. Okay, if it was a parabola going down, greater than would be there. Okay, so it kind of depends on the way the parabola is shaped. Okay, and then this one says actually to graph the system of inequalities. Okay, so this one says x squared minus 3. Okay, so negative b over 2a is my x value. Okay, I do not have a b, so my b is going to be 0. And 0 take away 3, so that means my vertex is at 0, negative 3. So 0, negative 3, okay, which is also my y-intercept. Okay, and then it's going up, and my pattern is going to be 1 times 1 over 1, 3 times 1 over 1, so it's going up 1, out 1, and from those 2 points, up 3, out 1. Okay, so it's going to just look something like this. Okay. And it's greater than or equal to. So then I'm going to shade in the greater than or equal to region. Okay, equal to, which is why it's a solid line. And now let's look at my other parabola, and I'm going to do this one in a different color so you guys can see. Okay, so my x is going to be negative b over 2a. Well, my b value is 0. Okay, so that's just going to be 0. If I plug 0 in there, I get 0, 2 for my y value. Okay, so 0, 2. Okay, and this parabola is going up, and it's got a pattern of 1 over 1, 1 over 1, 3 over 1, 5 over 1. So up 1, out 1 on both sides, up 1, 2, 3, out 1 on both sides. All right, and it is less than or equal to that one. Okay, so less than would be below it. Okay, so that means I'm just going to shade between these two. Okay, because it's less than the pink one and greater than the blue one. Okay, and then it would continue, you know, being shaded between them for as high as we could go. Okay. All right, let's take a look at the next one. So this one says y is less than or equal to x plus 4. Well, this is a linear equation. Okay, so it starts at 4 and it has a slope of 1 over 1. I'm just going to draw a few here so that I get kind of a straight line. Okay, and then we're going to go on ahead and do the parabola. So the parabola is y is less than or equal to x squared. Okay, so this one right here, if I do my x equals negative b over 2a, it's going to be 0. Okay, and if I plug 0 in for x, then I get 0. So my vertex is 0, 0. Okay. My pattern is going to be up 1, out 1 on both sides because my a value here is 1. Okay, I guess I could do this one in blue for you. And then up 1, 2, 3, out 1, 1, 2, 3, out 1, And then up 5, 1, 2, 4, 5 out one. I'm just doing one more here so that I can see where they actually cross. All right, so both of these are or equal to also, so they're both solid. Okay, so it said for my line, it was below it. And it says for my parabola, it's below it. Okay, so I want to be where everything intersects. Okay, so where both of them are at is down here. Even though the line is less than here, the parabola is greater than. So we're not going to shade in between. If this had been y is greater than or equal to x squared, then we would just shade in between. Okay, but we need to be where they're both less than. Okay. All right, so that is it for chapter 3. Ask questions if you got them. Have a great day.